Well, hello, my algebra students. Boy, I'm moving slow this morning. Can't get moving, but we'll get her done. Oh, get her done. I like that. So, anyways, today we're starting scientific notation, and we'll spend the next 3 or 4 days on it. In fact, I kind of thought I wouldn't give any homework today so you can just rest after this video. And if you want to watch this video twice, now if you already know what you're doing, hey, we're in good shape. But scientific notation was thought up to deal with really, really big numbers and really, really small numbers. And in fact, it has to do with logarithms, which because of technology, it's not as important as it used to be. But if I have the number 20,000, do you see how easy it'd be to lose a zero or add a zero as you're writing through your papers? In fact, it was very common in the 1960s or 70s when Social Security started up that someone would get like $100,000 check and they're supposed to be getting like $100 or whatever because people would just type in the wrong numbers. So what they did is they said, hey, we'll change this to 2 times. Now I'm going to use a dot. For scientific notation, they usually use an X. I don't know why this is a foggy screen. But 2 times 10,000. Then they said, wait a minute, 10,000 is 10 to the 4th power. And in 0.03, you could write that as 3 over 1,000. And if you remember your scientific notation, when you're dividing, you can bring it up, but you make it a negative power. And that would be a -3, because there's 3. And then over the years, they said, wait a minute. All you really have to do is count how many times you move the decimal. That's your power. So if I have 4, 6, so if I'm talking about the government and the budget, that's a very small number for them. They deal with trillions. In fact, we're going to be over $3 to $4 trillion in debt this year added to the deficit, which you'll have to pay off because my generation loves to be in debt. So what you can do is first we want a number to be between 0 and 10. I change that. 1 and 10, 1 and 10. I said 0, I meant 1. So what I'm going to do is just keep moving the decimal till I get a number between 1 and 10. So that'd be 4.6. That should be the easy part. Now, if you want to use an X, that's okay with me. You're not really supposed to use X for multiplication. So I'm going to use a dot, hopefully most of the time, but I forget sometimes. Then I have a 10, and how many 10s would I multiply by to get back to the original? Well, how many times did I move the decimal? 1, 2, 3, 4, 5, 6, 7, 8. So I'd have to multiply by 8 10s to get back to the original number. But notice how much easier that is to write. A 4.6 and 10 to the 8. Easier not to make dumb mistakes. So if I have 0.00000084, you say, well, Mr. Murphy, that'd be easy to lose a 0. So what I'm going to do is move the zeros 1, 2, 3, 4, 5, 6, 7, 8 till I have a number between 1 and 10. And since the original number is smaller, well, I guess I'm going to be using X's. I'm so used to it. I'll try to use a dot. It's going to be a negative power, meaning the original is smaller. So if I have 7600000, and if I have 0.000045, change that to scientific notation for me, please. Okay, so move, it'd be 7.6, that should be free, times I got 1, 2, 3, 4, 5, 6, 7. I moved the decimal. So it'd be 7 tens I'd have to multiply to get the original number. This one. So move it. 4.5. That should be the easy part. I want the original smaller, so it's going to be negative. And how many times did I move it? 1, 2, 3, 4, 5, 6. Woohoo! Now, what if I'm given the scientific number and I want the original number? Sometimes they call it the expanded version or the original. So, I'd have 6. Now I'm going to move the decimal 10 times. So 7 be 1. Then I have 9 more movements. So 1, 2, 3. 1, 2, 3. 1, 2, 3. So that's my original number. Woohoo! So if I have 4.3 times 10, oh, there I used x's again, didn't I? 10 to the negative 7. So I'd have 4.3, and I'm going to move it 7 times smaller. 1, 2, 3, 4, 5, 6, 7. Here's my decimal. Put a 0, 0, 0, 0, 0, 0. Easy peasy, chocolate cheesy. So do these two. 5.9 times 10 to the 12th. Holy cheese. And 3.1 times 10 to the negative 6. See if you can figure those out for me, please. Okay, this one, we got to move that decimal 12 times, or multiply by 10 12s. Every time you multiply by 10, you move the decimal. So it'll be 5, 9. I still have to move it 11 times, so that'd be 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woohoo! Woohoo! Aha! Starting to get some big numbers. Government love to spend that money. Now this one, you move it over 1, so it's 3, 1. I still have 5 more to go. 1, 2, 3, 4, 5. Now, if you're talking about outer space, the government budget, this is huge. If you're talking about inside the body, when you take biology or chemistry, one of those, there's something called a mole. I think it's 10 to the negative 21 or 24 or something like that. Very tiny. Very tiny. So no homework today. You might want to watch this again to get it down. And tomorrow we'll work on this again. Then we'll start doing a math. Adding, subtracting, multiplying, dividing with scientific numbers. And we'll probably spend all the way to Thursday on this. Then we got to do a geometric sequence. Couple days on that, and then it's fractions, and then we're done for the year. You know, we only have 17 more school days, not counting today. Hey, be happy.